Right, folks. Hope you are well wherever you may be. And today we are going to look at an alternative way of going through the 2021. It's the question 13 on the advanced physics section. There is a solution out there, and this is just another way of thinking about it. As well, just to enhance understanding about how to approach such problems, because of course time is always of the essence when doing these exams, so it's always handy to know other methods as well, which may may save you a little bit time as well. Right, so number 13, water enters a horizontal pipe of cross-section area given 0.004 meters squared at constant speed 0.5. Okay, at the end of the pipe, that's the cross section, 0.02 meters square. Okay, and we have been given what the density of the water is. How much power must be supplied to the water to maintain flow in this section of pipe? Okay, now, of course, this power term, just please note that this would, of course, be the average power and not instantaneous. All right, to maintain the flow in this section of the pipe. Okay, so what formulas are we going to be thinking of? Firstly, continuity. Mass continuity, so the amount or the mass of water in must equal to the mass of water out, conservation of mass. And how can we work out, if you like, what that inflow rate would be? We know that the rate at which the water enters must be equal to the rate m dot, simply meaning rate of, rate at which it leaves. Okay, now this here, if we just think about the formulas very quickly and just see the link. Now, density is mass over volume, okay? And so if we want to work out what the mass would be, this would mean that mass equals density times volume there. Now, the volume term here, if we want to work out the rate at which this liquid or the water is actually entering, we would have to then obviously use a modified formula, which would be given by the density multiplied by the area and given by the velocity, because this term here is made up of area times, if you like, length dimension. And if we divide this by time, this takes the velocity place. So that's velocity, and that's the cross-section area. And that's how we come about that term. M dot in equals rho AV. And that is evaluated as M dot in. Okay, so the rate at which the water, or the mass, the rate of change of mass with time. So that's 1,000. And the cross-section area we are given as 0.04. And we multiply by the speed. So we get this as, it's going to have units of kilograms per second. Yeah, as we have rightly seen from the formula before. So that would be kilograms per second. Now, if we want to work out the power, there's a formula that could help us work out the power or average power, which is given by force. If it's a constant force, multiplied by the average velocity. In other words, the average power equals force times the average velocity. It's actually a scalar product, but no need to go into such details. So if we can work out what the average velocity is, and if we can work out what the force is, then we should be winning. How can we work out the force? Well, we can use momentum, or the rate of change of momentum, which is in essence application of Newton's second law. The rate of change of momentum is always directly proportional to the resultant force. So what is, or how can we find, so we know that force is M del V, there we go, so to speak. Right, so we know what this M delta T term is, okay, and M delta T, or the rate of change of mass with, is given, and all we need to find really is we need to find what the change, because this here represents, that delta V is change in velocity. And the overall term at the top, m delta v, represents the change of momentum, delta p. And of course, delta p over delta t, or the rate of change of momentum, will give us the resultant force. Okay, right. So what is the change in velocity? How can we work out what the velocity will be at this side of things? Well, m dot in equals m dot out. The raw is the same. The area here, we are told what's happened to the area. The area has halved. And so how can we work out what m dot out is? All right, just equating those two. If it's now going to simply really be a case of the ratio of the areas, which would then dictate the ratio of the speed. So if we have to write this down as m in is equal to m out. And so we have m dot in out. Yeah. So just to make this a little bit clearer, this is V in and A in, and this is rho A out, V out. Right. And that's where the densities cancel out. So if I want to work out what the V out is, the velocity of the water out here, V out, is equal to A inlet over V in divided by A out. And what's the area? Inlet area, 0.04. Let's come down here. 0.004 multiplied by the inlet, which is 0.5, divided by the area out is 0.02. Not 2. Yeah, factor of 2. So we know that it leaves at 1 meter per second. Okay, so this change in velocity term, which we now are looking for if we want to work out the force, the change in velocity is now 1 minus 0.5 multiplied by this m over delta t, or the m dot term, is already been evaluated as 2 kilograms per second. Yeah, so times 2 kilograms, this will give us the force that's acting. And so the force now is evaluated to be 1 Newton. Running out of space here, so that's the force evaluated using this formula here. And the m delta t, that term has been evaluated as 2 kilograms per second. And we have noted that the change in velocity is given by a change of 0.5, so 0.5 times 2, and that's the 1 Newton. Now, power equals force times average velocity. V bar. Now, the force we know is 1 Newton, and the average velocity, well, it's the average, so we add and divide by 2. And this gives us 1.5 divided by 2, which is 0.75 times 1. And we get an answer of 0.75 watts. And so we get an answer of C. So that is an alternative approach. And hopefully that helps elucidate matters even further. Hope you all are having a lovely time wherever you are. And I shall see you at some later stage. Hope this was helpful. Bye now.